Welcome to the DIY Honda Garage channel. A Honda Accord models from 2008 to 2012 may encounter Diagnostic Trouble Code, DTC B1575, indicating a malfunction in the auto light sensor circuit. The auto light sensor plays a crucial role in determining ambient light levels and signals the vehicle's automatic lighting system accordingly. It is typically located in the upper part of the windshield, allowing it to effectively measure outside light conditions. A failure in this circuit can lead to improper functioning of headlights and other related lighting features, impacting overall visibility and safety during driving. Addressing this DTC promptly is essential to ensure that the automatic lighting system operates as intended. Understanding the associated components and their roles will aid in effective troubleshooting and repair. The error associated with DTC B1575 points directly to the auto light sensor. This sensor is responsible for measuring the ambient light level and communicates this data to the vehicle's control units. If it malfunctions, the automatic lighting system may not respond correctly, leading to potential safety issues during nighttime or variable weather conditions. The sensor is located in a position that allows it to effectively gauge the surrounding light, typically near the top of the windshield in the driver's side area. This sensor's functionality is crucial for a seamless driving experience, automatically adjusting to changes in light to enhance visibility and safety. Knowing its exact role and location assists in pinpointing issues during the troubleshooting process. Several factors could lead to the DTC B1575. A common cause is a faulty auto light sensor itself, which may prevent accurate light readings from being transmitted to the vehicle's systems. Another possibility is loose or poor electrical connections within the circuit, which can disrupt communication and functionality of the sensor. Wiring issues, such as frayed wires or poor insulation, can also lead to a malfunction by creating high resistance or open circuits. Each of these potential problems can contribute to the failure of the automatic lighting system and should be thoroughly examined during troubleshooting. Understanding these causes is vital in formulating the correct approach to diagnose and repair the issue. Drivers may notice several symptoms related to the DTC B1575. The most common symptom is inconsistent headlight operation, where the automatic lights may either fail to turn on or off as expected. As a result, drivers may find themselves relying on manual override to control their lights, which can be inconvenient and unsafe. Additionally, warning lights may appear on the dashboard, indicating that there is a fault with the vehicle's lighting system. Other symptoms could include difficulty in using other related features that depend on the proper functioning of the auto light sensor. Recognizing these signs promptly can help in troubleshooting the issue effectively and prevents further complications. The first step in troubleshooting DTC B1575 is to clear the diagnostic trouble codes using the HDS or Honda Diagnostic System. This process involves connecting a diagnostic scanner to the vehicle's onboard diagnostics port to reset the system. This step is essential because it helps determine if the B1575 code is persistent or an intermittent error. After clearing the codes, the technician should turn the ignition switch to the lock position and then back to the on position. Maintaining the correct sequence is crucial to ensure that the vehicle's systems initialize properly. This step ensures a fresh start in monitoring any potential issues, paving the way for further testing and diagnostic efforts. Following the initial troubleshooting step, the next action is to turn the ignition switch to the lock position and then back to the on position. This procedure is vital in reinitializing the vehicle's electronic control systems for a more accurate diagnostic process. After setting the ignition to the on position, It is important to wait for 1 second before proceeding to the next step. This brief pause allows the vehicle's electronics to stabilize, ensuring that all systems, including those connected to the auto light sensor, are correctly powered up and ready for any tests or measurements. This step is a fundamental part of ensuring systemic functionality before diving deeper into diagnostics. In the third troubleshooting step, it is imperative to check for DTCs using the HDS after reinitializing the systems. This involves using the diagnostic scanner to see if DTC B1575 is still present. If B1575 is indicated, it signifies an ongoing problem that requires immediate attention. Conversely, if the code does not appear, it could indicate an intermittent failure, suggesting that the system is functioning correctly at this moment. It is essential, however, to still inspect for loose or poor connections, as these could easily lead to temporary faults that may need to be addressed promptly to ensure long-term reliability of the lighting system. Upon confirming that DTC B1575 is still present, the next step involves turning the ignition switch to the lock position to safely conduct further diagnostics. Following this, the technician should disconnect the automatic lighting/sunlight sensor 5P connector. This connector is essential for the sensor's operation, and disconnecting it prepares the system for voltage measurements. Once disconnected, the technician should turn the ignition switch back to the on position, which powers the circuit associated with the auto light sensor. This step sets up for the critical measurement of voltage at the sensor connector, which directly indicates whether the sensor is functioning correctly. In step 5, measuring the voltage at the automatic lighting sunlight sensor 5P connector terminal number 1 is crucial. A multimeter should be used to assess the voltage between this terminal and body ground. The expected reading is around 5 volts. This specific voltage is indicative of correct sensor operation. If the voltage measured is approximately 5 volts, it suggests that the lighting sunlight sensor is faulty and requires replacement. In contrast, if the voltage reading is significantly different from 5 volts, it indicates a fault in the circuit or sensor connections, leading to the next troubleshooting steps to diagnose the underlying issue accurately. If the voltage measured in the previous step is not around 5 volts, the technician should turn the ignition switch to the lock position again to ensure safety. Next, the passenger's under-dash fuse relay box connector, D, which has a 28P configuration, should be disconnected. This step prepares the system for a continuity check that will help verify if the circuit is appropriately functioning between the two connectors. Checking continuity between the passenger's under-dash fuse relay box connector, D, terminal number 9, and the automatic lighting sunlight sensor 5P connector, terminal number 1, is essential to identify the health of the wiring leading to the sensor. A continuity test will allow technicians to determine if there are any breaks in the wiring or issues leading to high resistance that could be affecting sensor performance. In the final troubleshooting step, checking for continuity will reveal critical information about the fault's cause. If continuity is present, this confirms that the wires are intact and functioning correctly up to that point. However, if there is no continuity, it indicates that there is either an open circuit or high resistance affecting the wiring. This finding may lead to the conclusion that the passenger's microcomputer interface unit, MICU, is faulty, which would require replacement of the fuse/relay box. Conversely, if an open circuit is identified, repair actions should focus on locating and correcting the break or resistance within the wiring, which could restore the intended functionality of the auto light sensor circuit. After completing the necessary repairs, It is essential to verify that the repairs have effectively resolved the issues indicated by DTC B1575. Begin by reconnecting all connectors that were previously disconnected during the troubleshooting process. This ensures that all electrical connections required for the auto light sensor are secure and operational. Following this, the technician should clear the DTCs once more using the HDS. Once cleared, the vehicle's systems should be observed in action to confirm that the automatic lighting operates as expected without triggering the fault code. Successful operation without the reappearance of the B1575 code indicates that the issue has been resolved effectively. To prevent issues related to DTC B1575 in the future, regular preventive maintenance is essential. This includes periodic inspections of the auto light sensor and its connections to ensure that everything is secured and free from corrosion or damage. Checking electrical connections regularly can help catch issues before they lead to a malfunction. Additionally, routine diagnostics using the HDS can aid in early detection of DTCs, allowing for timely interventions. Maintaining clean and secure connections, along with regular sensor checks, will support optimal functioning of the automatic lighting system, enhancing overall vehicle safety and performance. In conclusion, understanding the components involved with DTC B1575, especially the auto light sensor and its circuitry, is paramount for effective troubleshooting. The steps for diagnosing and repairing this issue must be followed methodically for the best results. Every step from clearing diagnostic trouble codes to verifying repairs is crucial for ensuring the automatic lighting system operates correctly. Prioritizing these repairs not only helps in restoring functionality, but also enhances driver safety during varied lighting conditions. By adhering to recommended maintenance practices, vehicle owners can reduce the likelihood of encountering similar issues in the future, providing peace of mind on the road. Please like and subscribe to the channel. See you next time.